Okay, in this problem, you're asked to look at estimate the number of subintervals to approximate the value of this interval from -4 to 7 of 9 sine x plus 7 dx with an error of magnitude less than 2 times 10 to the -4th. And you can either use the trapezoid rule or the Simpson's rule. So I went ahead and checked my answers, and I got these two answers. I just want to show you how to get these. There is a formula. It's kind of funny because like this problem, it seems like you could go ahead, you could do it. It seems like you would be able to do it by hand, but you could get an exact value, but your calculator would still have to be used to approximate the antiderivative or the cosine of, when you do this antiderivative, you get negative 9 cosine x plus 7, and then when you plug in -4 and -7, you still be getting approximations. So using the trapezoid rule is kind of an interesting approach. So for the trapezoid rule, what you're going to want to do is you have this error bound here, and you're told that you want your error to be less than this 2 times 10 to the -4, which means move your decimal to the left 4 places. So this is 0.0002. That's what you want your error bound and absolute value to be. We have this m and then b minus a, which is, this is your a and this is your b. So this is a is -4 and b is 7, and n is what we're looking for. So what is this m? M is the upper bound of the second derivative over the interval. So they just do a little algebra here, cross multiplying, and then divide both sides by 12 and times the absolute value of the error term, and then, or the amount of the error, and then take the square root to solve for n. So this is the formula we need to plug in and figure out. All right, so f of x is this 9 sine x plus 7. So the first, we need to get the second derivative. The first derivative then is going to be just 9 cosine x plus 7. The second derivative will be negative 9 sine x plus 7. Now, you need an upper bound. Well, if you think about the sine function over any interval, the most it'll be is 1 and the least it'll be is -1. So if you multiply that by -9, you should be able to reason to yourself that the very largest that this can be is +9. And so that is the number that you will use for m. M is going to be +9 because that would be the upper bound of the derivative. And then you're just going to plug that stuff into this formula, and I'll come in here and use my calculator to do that. So we'll just do the square root, so second square root of the m, which was 9, times the b minus a, so 7 minus -4, and you're going to raise that to the third power, and then you want to divide by the product 12 times the error term, which was 0.0002. Close that parenthesis and close that parenthesis. Let me show you how I type that into my calculator, and then you just hit enter, and it gives you that number, and you always want to round up. So that's how we got the 2,235. So to use Simpson's rule, it's the same. It's pretty much the same process. It's just a different formula for Simpson's rule. Simpson's rule is a little bit more accurate. Here's the error estimate, but you need the m now is an upper bound for the fourth derivative, so you're going to need to keep taking your derivatives. Your second derivative was -9 sine x plus 7, so your third derivative is going to be -9 cosine x plus 7. And then finally your fourth derivative is going to be equal to 9 sine x plus 7. And it's the same logic again, that the upper bound on any interval will be 9 because the sine function fluctuates between -1 and +1. And so if you multiply it by 9, the most that it could ever be is 9. So you put 9 in for m, and then the rest of this will be the same. So we'll come over to our calculator and just kind of type that in. So in this case, we're going to do 9 times the 7 minus -4 raised to the 5th, and you're going to divide that by the 180 times the error, which was 0.0002. You have to close that parenthesis in the denominator because you have multiplication there. And then close the parenthesis on the outside and raise that to the 1/4 power, which is also going to have to be in parentheses. Enter. And then this rounds up to 80. But if it had rounded up to 81, you'd actually have to pick 82 because you have to choose the nearest even whole number because Simpson's rule requires that you have even numbers. Hope that helps.